Now, that largest slice that we were looking at earlier was some form of communication. So when we say communications in space, what are we actually talking about?
It can mean many things.
Yep.
I mean, every spacecraft needs communication to send commands to the spacecraft and to get data back down again. But this is particularly meaning things like direct broadcast TV, satellite radio, satellite phones, and things like this. So for anything in space, you've got to ask, why are you doing it from space and not from the ground?
Yes.
I mean, if I want to call my grandmother, why would I involve space in the whole thing at all? So the fundamental reason why you use space for this is that the Earth is a sphere and it's curved.
Yes.
So if you want to communicate from here to here, you can't send radio waves because they have to go through the Earth, and the Earth doesn't pass radio waves very well.
Unfortunately.
So that's the fundamental reason why radio communications are short-ranged.
Okay.
That there's this curvature of the Earth.
So you need kind of more line to sight.
Yes, it needs line of sight. Now you can get around it a bit if you use low-frequency radio waves.
Okay.
They sometimes, if all is well, they can bounce around the ionosphere. We have a layer of ionized gas up in the upper atmosphere, and you get signals that can bounce up sometimes multiple times around.
Yep.
So it only works for low-frequency radio waves. It's a complete curse for the radio astronomers trying to do low-frequency astronomy, as we both know. But this is how people could listen to the shortwave radio from around the world. But it was very iffy. It depended on
What was
how the
going on.
ionosphere was going on at that time.
So not possible, but not reliable.
Possible but not reliable, and also low-frequency radio waves don't carry very much information.
Yes.
So you can maybe carry a few radio channels, or maybe one or two telephone communications.
But you're not sending videos and data and a ton of information via that way.
Right. So as originally proposed by Arthur C. Clarke back in the 1940s, the idea would be we can get rid of the line of sight problem by putting a spacecraft. And the idea is to put it in a geostationary orbit, because that way it can just hover over one point on the Earth, and you can just have a fixed dish on Earth that sends a signal up to it. Some of the early ones was basically just like a giant mirror up there. It was like a giant reflective ball that would bounce the signal back down again. But it's nowadays they're much more. They have solar power, and they'll pick up the signal, amplify it, and then broadcast it back down again. So they're active spacecraft.
Yep.
And this allows you to get message from A to B, even though A and B are on opposite sides of the Atlantic or the Pacific, as long as you've got a satellite in a geostationary orbit hovering midway across your ocean.
That's right. So if you have enough of them spaced around those spots, you can talk to anywhere at any time.
That's right. And on the ground at each end, you can have a fixed dish, because it always appears to hover in one place in the sky.
So you're always pointing at that same spot?
You can just concrete into the ground. You don't need to have it movable. You adjust it till it's pointing at the satellite.
And then I guess in this case, if you have multiple satellites in multiple positions, you just build them at multiple angles.
Yes, and you'll see these sort of dishes on the roofs of many government buildings and communication centres. There's a park we drive past on the way out to Mount Stromlo, which has a bunch of these things.
Yes.
So, and they're very common. And so this, for a while, was if you wanted to make a phone call from England to America, this is how it would go. It meant there's a bit of a delay. There's a high latency because the signal has to go all the way up to geostationary orbit, 36,000 kilometres and then back. And even at the speed of light, that takes a bit of time.
That's right.
So it's not too bad for a phone call or something like that.
Yep.
Now, this for a while was the big thing in space, but you couldn't get that many phone channels.
That's right.
And need big dishes at both ends. And it was replaced by fibre optic cables. Of course, even before satellites, you could still have copper cables across the ocean. But again, you can't get much of a signal down a copper cable. You can get a few phone lines, but they were very expensive. You read all these old spy thrillers from the 1960s, and we're going to make a phone call to America, and this was a big deal that you booked in advance.
That's right.
But fibre optic cables, which now cross the world's oceans, can carry vastly more data. They're the backbone of the internet, and there's a huge number of these cables.
So these are these underwater sea cables that go pretty much everywhere.
Yes, and a single strand of fibre optic can get so much data down. They've made long-distance communication satellites kind of obsolete for these sort of purposes.